Hi, this is my intro to Physics Lab 1.
This is the tracker program that we are going to be used to analyze the motion of the ball. I chose to use the frame from 119 to 129. I chose to use this frame because at the beginning the ball is speeding up and near the end the ball is slowing down, so the velocity is not constant. I added a calibration stick right here to show the real life length of the tennis ball, and its diameter is 0.067 meter in SI unit. The coordinate system I place right near the center of the mass of the tennis ball. Over here is the positive x direction, negative x, positive y, and negative y. The ball will travel along the positive x direction. After that, I also made sure to change my clip setting into a frame rate 30 per second. Now I am ready to use a track control on a tennis ball. And basically you just hold down shift, and every time you touch the center of the ball with your mouse, the frame will move on and tracker will track where your ball motion is. And after you're done with that, it will look like this. As you can see on your right, the graph plot out the point where the ball is with respect from time to position. And here's a table for easy identification. So now we're gonna go and edit the Python code to make a computer model to represent this.
Here, I would like to point out that after the while, you have the fnet vector and then the ball.vl, the ball velocity. Here we are applying Newton's second law to predict the new velocity, and then using that velocity to predict the new position. And then after the delta t time, we repeat the whole process.
So now we are going to run the program. As you can see, the ball is moving to the right at a constant velocity. We can extract this data into a graph form. I use Google Spreadsheet. As you can see, the model versus the experiment graph is here. The model is following Newton's second law and giving a linear equation, while the experiment started off as similar to the model, but then the tennis ball must have slowed down or stopped traveling in a straight line. That's the reason of the divergence from the model linear equation.
So now the question, what if? If we would have changed the orientation of the axis, then the ball would just travel in the opposite direction. I will show you now. If we change the velocity to travel into the negative x direction, it will just run in the opposite direction. The second question is, what does it mean when my observation can be predicted well by a computer model when you set the net force equal to 0 in your model? Is it possible for me to say how many pushes and pull were added to give the zero net force in the case you observe? The net force is 0. That means that every force acting on the ball is balanced out. So it could be like an infinite number of forces, but as long as the forces balance each other out, giving us a zero net force, then everything is okay. Well, thank you for viewing my lab report. Have a great day.